Okay, let's get started. This is Auto IETF 112 meeting, virtual meeting. My name is Qing Wu. The first thing I want to mention is Yan, my co-chair. Uh, he got sick, cannot make it, but we are fortunate to have Mohammed Bogdar to be the acting chair. So welcome, Matt, to help moderate the discussion. And so we will have actually coded. We have a hedgehog actually collaborative meeting taken towards and for agenda and slides, and you can get access through the link. Nodeware, as usual, Nodeware tell us how IETF is operating, including IETF process, policy, and rules, and IPR. And one thing I want to mention is our ISG encourage all the working group chair to highlight the code conduct. So for the code of conduct means you should be courtesy to the colleague, focus on technical discussion, focus on the topics. We have bunches of PCP. If you are not familiar, please read it. Administrative. So the session will be recorded. So we'll use the media echo queue control. If you want to speak, please enter into the queue by press the raise hand button. If you want to leave the queue, please have a second click the raise hand. And before you speak, please unmute yourself. And after speaker, please mute yourself. For audience, especially you can mute your video stream. And we also have Jabber, and it will be served as a side comments, and we'll keep track of the side comments. And if you want to speak before the mic, but you cannot make it, please put at the mic, and we will forward the comments to the meeting room. And the blue sheet, we have electric blue sheet, so your attendance will automatically recorded. Notes taking, we have CodeMed, CodeMD, and the Hedgehog Doc tools, and I think we already have Adrian and Daniel have to take a minute. If you want to add additional minutes, feel free to do so. And so this is the agenda for today's discussion. So the agenda is very tight. First, as a chair, we'll introduce the working status because we have our new charter get approved. So thanks, Martin. And especially want to highlight the two working group document status update because there are some open issues that need to be checked. We want to make sure all the comments are addressed. And for today's discussion, we'll focus on charter item. We have two charter items. The first one is Auto OM support, and Jason will lead the discussion. The second one is Auto OM over HTTP2, and Richard will lead the discussion. And also, we have a deployment experience update. We received two deployment updates. One is from G2, the second is from Flow Director, and we actually already have a discussion with G2 team. So Kai will introduce how G2 is integrated with the Auto. The second is Flow Director. Daniel will give update of Flow Director, and hopefully this will be good input for the Auto deployment. And after that, we'll have three non-charter items. So the first one is Auto as IETF network exposure function. The leader will be the Luis, and the second is compute-aware network use cases. We'll invite Liu Peng to introduce these potential new deployment use cases. The last one, we'll invite Liu Zixiong from Nanjing University to introduce bandwidth estimation on OpenNet Lab. After that, we'll wrap up the discussion. And agenda batch. Okay, let's move on. Actually, we working remotely. We are already familiar with working remotely, but I want to highlight three things. The first, we should utilize the mailing list. So usually the working group consensus is judged on the mailing list. Today we have the important discussion in this meeting, and we also have periodic interim meeting and informal meeting. And usually the working group decision is made on the mailing list. So please actually start. It's important to actually close down the topic and to show the topic get it done. And also it's important to start a new topic. So if you have any new idea, please publish your document and make an intro and a summary of what you do on the list and begin the discussion on the list. And also for the next IETF meeting, probably we have hope can have a mixed meeting, both online and in person, but it hasn't been announced yet. But let's stay tuned. And last, and we have online meeting, and also we have informal meeting. If working group think we need to have this kind of resource, we working group chair can arrange this kind of resource. And so this is auto working group charter. So we for this charter we actually have two important deliver. One is auto OM. The second is auto new transport. In addition, we can cover the auto deployment update, and so we also can explore the use case and protocol maintenances. So you can see we have three deliverable. And so for the auto deployment challenge, we have documented in the wiki page or internet draft. And we actually break down the charter item into several categories. And you can see the first two, actually, we already have a relevant individual draft. So these will be our focus of this agenda discussion. And we also have non-charter item actually have a bunch of draft. Hopefully it will serve a good input to the auto deployment update. And we also have implementation deployment tracking. So you can see actually for client we have 2 implementations, server we have 4 implementation. If you have been aware of any new implementation, please let us know and we'll update this wiki page. And this document update, we already have 4 working with draft actually ready for IETF, IESG telechat arranged at December 2. And so today we will discuss the 2 documents which actually has some open issue. So that's it. Let's move to the first topic. I think it is Gao Kai.
Yep. Hello everyone. This is Kai. So Chen, can you share my slide?
Okay. Go ahead.
Okay, so this is a presentation about open issues raised in the last code reviews for auto path vector extension. So next slide, please. And for GenArt and ArtArt last code reviews, we have both gives the some minor issues. And for the reviews from OPSDR, and we actually had not ready. So the main content of this presentation will be on the reviews for the OPSDR. So next slide, please. And for art and Gene art, we actually most of the issues are matter or need issues. So from the art, we have one issue is the use of content ID does not conform to previous RFCs. And also the second issue is we need IPv examples for IPv6. So next slide, please. And we have made the revision for the first issue, basically the use of content IDs in the last revision. And we defined the format to be compatible with RFC 2003 87 and 5322. And we also had revised the protocol specification and examples to accommodate the changes for the use of content ID. So next slide, please. And actually, we most of the open issues comes from the review from OPSDR, and we have classified them into four major issues. The first is the reviewer asks for more real use case and examples to better clarify the extensions in the document, and also there are some concerns about the clarity about the concept of abstract electrical element. And then there are some terms that may not be very clear that may trigger some ambiguous meanings. And the last is the reviewer asks for some examples that the path vector can be used in practice. So next slide, please. So this gives the review for the first issue. So basically, the reviewer is asks for argues that in the 17 version of path vector, and the use case section does not reflect real traffic steering objectives of existing systems, such as the LHC project. And also some specific examples of ANE are needed to show real use cases. And also some discussion and examples for identifying bottlenecks are needed. So next slide, please. And in our latest revision, we actually have introduced more detailed examples about how this extension can be used in practice. And the examples are extracted from existing systems that where we thought that where we believe that this extension can be used or be integrated into these systems. And for details about these examples, please refer to the latest document. So next slide, please. And the second issue. Oh, wait a minute. And we also sorry, I don't see the screen. So which slide is this? Page 8, right?
Yeah, page 8.
Oh, okay, page 8. And the second issue, there are some specific examples of ANEs are needed to show real use cases. So we actually give the example, for example, how for the use cases that we presented in the last slide, we actually also list how the different network components will be considered as ANEs in a specific use case. And we also refer to these use cases to their like research papers or other materials. So next slide, please. And to address the issue of identifying bottlenecks, we actually first we point the related studies, so readers of the document can refer to these research papers to understand how the bottlenecks can be identified. And we also put some actual concrete examples in the document to show how path vector can help expose bottleneck information. So next slide, please. And for the second open issue, basically the reviewer asks for clarification examples for abstract letter element. So first, we give some examples in the use case section, and also when we specify the meaning of abstract letter element, we put another example there to show that different objects, if they have the same property, then they will be triggered as like equivalent abstract letter elements, to basically to give a better sense of how different network components can be considered as the basically why we use the meaning of abstract network element to basically show some common properties of different physical entities in the network. So next slide, please. And for like some terminologies that the reviewers might find ambiguous, we actually revise these terms to avoid ambiguity for the meaning. So next slide, please. And for the last issue, basically, we need to give some pointers for how the clients can use this extension to orchestrate the traffic. First, we also give some examples and pointers when we demonstrate the use case. And it is emphasized in the documents that auto is only used for information exposure, and traffic steering is done by the application.
Okay, can you wrap up in 1 minute?
Yeah, sure. Basically, I think the next page is basically a summary of what we have done in the last revision. So issues from the last core reviews are addressed, as from my understanding, and we're actually waiting for the reviewers' feedback. And it will be, so we have one question for the working group is, how do you suggest that we proceed with this document?
So I see Martin up. Martin.
Okay, thanks. So to be clear, all those diffs that you showed are present in the latest version of the draft?
Yes, yes. I think these changes are already in the 19 version.
Okay, excellent.
In version 19, this is the latest one.
Okay, good. I just wanted to make sure that the IESG has it. It would certainly be nice if the last call reviewers responded to your changes, but I don't view that as necessary. The other ADs can do what those can, judge whether or not you've addressed this. So I think we're fine to proceed to the ballot, which will happen on December 2nd. Yeah,
I see.
I mean, by all means, if you, I believe you have already, but email the reviewers and say, hey, we made these changes. Please look at them. But
yeah, I already sent them the emails. Yeah, but I didn't get the feedback yet.
Fair enough, right? But we're not going to block on last call reviewers being responsive. Thanks.
Okay. Thank you.
Okay.
Yeah, I think that's all for the talk. Thanks, Jim.
Okay, thank you. Let's move to the second topic, Richard. So let me share your slides.
Yeah, thank you.
Here you go.
Okay, can I start?
Yes, go ahead.
Okay, great. Yeah, and for the performance metric document, we received the Gen Art review from Alvin Davis, very nice review. And then we also got art review from Christian Amsius, and they are also very nice review. The main changes was to address the reviews. And there's one remaining thing which we have not really confirmed yet, but I'll go over what it really is. Okay, so next slide, please. So here, the main thing we changed and to address the Gen Art and art reviews, basically we made changes from version 17 to version 19, and would be number one is mostly clarify the definition of cost metric string, mostly came from the art review from Christian, and also of course clarify the INA considerations that from AD, from other reviewers as well. And then the last one, in terms of high level structure, is ongoing discussion with the Gen Art review, Alvin, and mostly about is cost context parameters. if you want to get a little bit reminder, and the cost context parameter is on the lower right corner. So that's one which we're still trying to really reach the final decision with Alvin. I'll go a little bit of details, but those are the high-level changes we made. So now let me first went over the first change, which is triggered by the review by Christian. And main issue here is he wanted to clarify the grammar. So if you look at it, and in the early version, we give a formal grammar, which there's all these email exchanges in, of course, public email exchanges. We use some kind of like a grammar. And then the discussion or the suggestion eventually from Christian is maybe just use some kind of English description about what a cost metric read string really is. And we agree with it because we looked at the authors looked at the multiple ways to specify the grammar, and everyone looks like slightly more complex than necessary. We're not really dealing with a very complex grammar, which is dealing with what exactly the format of a cost metric string really is. So eventually, we adopted the paragraph which shown over here. Of course, it is in the newest version. So the definition basically is optional base metric identifier. Of course, by the way, everything in quotation means they are the real text, and would be base metric identifier followed by an optional statistical operator string. That's a new term, but of course only editor, not content change. And then I think there's discussion about using dot or column. Eventually, we decided to really adopt column because the reviewer said would be, look, you already have PRIV column, and so why don't you use essentially? My understanding is why don't you just do the same thing? So therefore, we adopted that small change from the previous version. Now become like a column. So therefore, if you set examples, it become delay one way and delay one way column mean and delay one way percentile 99. So that's the one change. And also the same review comment by Christian is a discussion about what exactly how to specify which statistical operators you want to use. For example, what if it is a maximum reservable bandwidth? You already have a max, and which one is a good metric? So originally we recommended using, for example, mean, and
Richard,
after discussions. Oh, go ahead. Too slow.
Richard, you have 1 minute.
Oh, 1 minute. Oh, okay. So basically, I think this one address, I don't. We're pretty happy about it. So next one, please. This one is the INA consideration, and we add all these paragraphs. And in particular, we clarified from the review that for any new value or cost metric and profit metrics, you must include the three things: identifier, intended semantics, security considerations, and that part also addressed. We're pretty happy about that. Please, next one, please. So the only opening issue is how much information we want to really give to this the parameter field, which is in the right like a rectangle. And the main issue, I think, the main review comments, and that one from JR from Alvin is, how much do we want to make this one to be machine readable? So therefore, the current version is we're using JSON value, and I think the working group early discussion was let's make it opaque. But then the discussion from the reviewer is how much you want to make it to be machine readable. I think that's the main issue. We did talk about it, and to really answer this question, we really have to ask ourselves what exactly why machine want to read about it, and in which sense machine want to read instead developers would read about it. And so therefore, we talk about there are essentially two cases you might want a machine to be read. Number one is whenever you have, for example, look at estimation, the rightmost column, and you might want to tell them which estimation algorithm you use to estimate one-way delay and TCP throughput and so on. For example, later today you will see Kai and talk about the G2 work, which uses maximum fairness, which is a SICOM paper, and I believe trying to be deployed in ESNet and so on. And of course also can be using, for example, in the current version, we talk about using profit. So therefore, one way is maybe really an index to talk about it is which method you use. The second way we identified and how much we want to make a machine readable is maybe you want to give some kind of detailed parameters. For example, when you are measuring, for example, loss rate, you are measuring every 10 milliseconds instead of every 100 milliseconds, or averaging statistically, of course. I mean, we're giving longer term value, but the measurement itself, examples might come from some parameters. So overall, thinking about this one, we still believe a generic link parameter is probably the best way to go. So therefore, your application would be able to know, okay, and I get, for example, what method you are using and which are the parameters, and we can get initial deployment. And then if after we have some experiences, we will work with, eventually, I think we can offload some of this work to this the bits of 79, 71 and auto deployment. So eventually, if like some kind of very public way to specify those parameters can become public, and we can make them into the deployment considerations instead of right now holding on this particular way, because earlier working group did talk about this one for a long time. So we're waiting for the feedback. Yeah, we're still waiting for the feedback from Elwin, and I think we'll ping him again, and we want to discuss. Hopefully, we can reach a consensus as soon as we can. Yeah, that's a backup slide. You can go back.
Okay. Any comments from audience? Yeah, Martin.
Machine readable thing. We talked about this during the AD review prior to that, and ultimately, yeah, there's probably some value for debugging, and I could imagine a particularly power user like looking at the stuff and deciding if an Alto server was like good enough based on what the numbers were. But ultimately, for this to be useful at all, you have to write scripts that say ignore the results if I'm unsatisfied with the criteria. So that implies a registry and all that. So it doesn't have to happen in this document. It's a little late for that, but ultimately, yeah, it doesn't have to be a long document or a BIS, but just something saying defining a registry, and then
sure.
I think that's where this has to go for it to be worthwhile in the long run.
Yes, exactly. Totally agree. So okay, Martin, to clarify, by the way, all the things I talked about already in the latest version. That's the only one. We're still ongoing discussion, but we're not making any changes on the target yet. Great.
Okay.
Okay, let's move to the next topic. I think it is Jason.
Okay. So I just
do you want to share slide by yourself or? Okay.
Let me find slide.
2 minute slides. You need to select one.
Yeah.
Okay.
Yes,
go ahead.
That's one. So this is presentation for the new items about the young data model for the auto OEM, and apparently still early work, and we try to summarize the what's the scope and what's the requirements for this work, and we give some initial proposal for the current data model, and we have many open discussions in the mailing list in our previous meetings. And the main goal for this work is we try to define the young data model for the operation and the management purpose for the auto protocol, because this is the blank perf for the auto working group. We already have some extensions for the auto services, but we don't have any standard for the operation and management purpose. And the main reference we make this work based on the RFC about the base protocols and the deployment considerations. The latest version we already upload to the trackers, but because we still have many discussions online, so we have some quick iterations on the GitHub. So if you want to check the latest version, you can go to GitHub to check the latest one. And this table will give the base requirements we summarize from the base program RFC. So we think this summarizes all the base requirements. Like in this work, we're trying to support the configuration for the auto server setup. We define the management information base to support the configuration for the data cells, the information resource generation algorithm, and the access control at the information resource level, performance monitoring, and some configuration for the security policy management. But before we go into some details, I want to make sure. So I want to make clear what is the scope in about this work. So I think in the scope of this document, we should suppose we should define what is the data model for the auto server or the client operation and management. We define some data model for the functionality of capability configuration for the different auto services. We also need to define the performance monitoring for the operation purpose, but what is not in the scope, I also want to make it clear. So in this work, we're not trying to define any data models related to any specific implementation. So for example, we're not trying to give any specific data structure about how to store or how to deliver any auto information resources, like the network map, the cost map, recovery map, and some other information resources defined in the extensions. Also, we're not trying to give any data model to define any specific algorithm about how to generate the auto information resources. Also, we're not trying to define any specific data structures about how to store the information collected from the different data sources. So I'm trying to make it clear in this document at the beginning. So now, so based on this base requirements, we make the objective in the document earlier. So in this document, we focus on these four main objectives. So we support the configuration for the auto server setup and provide the configurable data models for administrators to create, update, and remove the auto information resources. For this part, it should support the different types of the data sources. It can allow the developers to augment the new APIs. We will not try to define any specific algorithm, but we allow developers to augment the data model to support their own algorithm interface to generate the auto information results. And we also allow the future new extensions can extend this data model to support the new information resources in the future. And so this data model also includes some statistic information for the performance monitoring and the security policy part. But the current version of this document we only have our current progress. We only focus on the second and third part of this objective list. So our current initial proposal focus on these two parts. So this is the current the initial proposal for how the operator can use this data model to create an information result, and the operator can write this data model to specify a new auto information resource. Like it can define a new auto information resource by specify some common parameters like what's the resource ID, so what's type of this auto information resource, some base access control, the dependency about this information resource, and some other auto information resource like the cost map depend on another network map. And also for the specific information resource, it can specify some resource specific parameters. And the main part is that it should specify some kind of the creation algorithm. And this creation algorithm is provided by some other developers. It can augment this model. Like let's give an example. Like we use the layer 3 unicast class algorithm to generate a network map from some other data sources. Okay. And the operator can import some different kinds of data sources from different protocols. The BGPRS, the SRS data, the PCE data, and some other network management data. And for the data source import, the operator can specify what mode to retrieve the data. You can use the reactive approach, like you can use some pub/sub mechanism, or you just use the proactive polling mode to periodically to get the data. And for the different data source protocols, like if it's a data from the address, can use the maybe get from the YAML data store, and how it is a network management information. It gets the data from some other network management system, like the Prometheus and some other devices. So for the algorithm, we have some examples proposed by the different other individual like so this one gives an example how to translate the SRS tuple to the network map. And we also have some use cases like can translate some data from the PRIV and the SMP devices to the property map. And also we have an example to translate the BGPRS information to the network map and cost map, create the related auto information resources. And for the statistic information in the deployment consideration RFCs, it already suggests some memory information should be supported by the auto server, like it should support some application performance information and some system and service performance, like the request response for each information resources, and CPU memory utilization, the auto map update, the number of PIDs, and some other like the auto map path sizes. But we also have some auto extension, like the cost calendar, the SSE, the unified properties. So they all have the different memory information. Also be useful to be collected by the auto server. So this data model will cover all of this information. But where we still have some also missing part not covered by the current data model. They will be considered in the future versions, like how to configure the server discoveries and how to support small the data source retrieval mechanism and some partial computation support and more options for the security policies. Also have some discussion on this part. And the data model for the lifecycle management. And following the following slides, I try to summarize some main items we generate from the online or the mailing list discussions. Like the secretary we propose some comments like this document provide any generic network models like the Sonic SAI, or the model from Google papers. We're trying to actually the provide generate network model is not in the scope of document, but we did try to define some common interfaces to connect the auto information results to other auto information results and the related data source. So that we think this can be useful for this document. And also do try to understand how to understand the interface for the information resource creation. So it did not make the decision we use the intent-based. The creation interface should be intent-based, but in this document, we try to make this creation interface be reactive, like if the operator configures connection between the information resource and some data sources. If the data source change, that means the created information resource should be automatically updated. And also, because in the early version, we separate the data source import to the internal data source and the external data source. But in the latest version, we remove this part. We think we don't need to differentiate the different types of the data sources. We allow the developers to augment the common data model for the data source to find how to connect to the different specific data source. Also, we think this is the important part. So this is still ongoing work. Also sent some mailing list discussions with Qingwu, like how to support the server discoveries and how to support the lifecycle management and performance monitoring, and how to integrate the different kind of data sources. This part, we also have some discussions in the mailing list. And finally, internally, also have some discussions about how to define the data model for the auto client side, because the current data model only focuses on the auto servers, but actually in the scope, auto client configuration is also in the scope of this document. But we need to clarify actually the use cases. Who will use this data model to configure the auto client? It's not useful for all the auto clients, but for some specific use cases like the network application integration cases or the multi-domain cases, they may be useful. And also for the security part and the performance monitoring part, and also give some comments about how to refine this current data model. I'll thank the feedback from the online meetings and the mailing list. And if you have any other feedback, it's welcome to email to the working group and CC the others. And also you can open the issues in the GitHub. I'll see it and reply to you. So we're looking forward to receiving all your feedback. Yeah.
Okay, thank you, Jason. And so thank you for checking this work. Actually, good summary for the discussion on the list and offline. So I think this work is very important work in the charter. So which is the missing part in auto deployment RFC. So therefore, this work I think should closely align with auto deployment RFC and also other protocol work. So first step for this work, I think we need to make it clear what is in the scope, what is out of scope. So I think that there's three most important part. One is information source management. Second is data connection, data source. The third is infrastructure monitoring. So you already touched this, but I think this need to be further cooked. So with this, any other comments from audience? Richard, go ahead.
Martin first or I first?
I think, yeah, you can be first.
Okay, yeah, just want to make sure follow the queue. Very quick question. One complexity of auto server configuration is the algorithm to compute the network maps, because that's oftentimes a foundational service. So, but oftentimes that will be very algorithmic, not like declarative, using, for example, like a young model. So what's a long-term solution for this one you want to address in this effort, OM effort? Some can be declared. For example, declare any network node is, for example, every autonomous system is one, or every federation, or for example, if you model a data center, which one thing I'm considering, then that potential can be declarative. But overall, most will be algorithmic. So how do you plan to address this?
I'm sure I understand the question correctly. So, but we're now trying to, yeah, let me switch to the page, maybe page 4. So I'm not sure if you are talking about so how to organize the data to present the auto information results, because we only focus on how to give the interface to create the auto information results, but not how to store out, how to deliver the auto information results. Like we mentioned the network map.
I'm thinking of you collect data, but you need to specify a way if you're doing management, and probably you want to specify a way how these multiple types of auto network maps can be constructed. So somehow in some way should be specified in some way to make a good management. But at the same time, specification can be very complex.
Got it. Okay. Yes, you maybe you're right. This part, this is the missing part in the current data model, but I'm not sure if the data model should cover this part. Because I think this is more like the implementation specific. Like the OAM system should consider how to implement the data management. If you collect the data from the data sources, how to store it and how to query it and translate to the.
So Jason, I suggest to take to the list. Yeah. So Martin.
Yeah, just very briefly on the Alto client thing. Look, I'm not an Alto practitioner, so I don't have the answers, but I just think that certainly that's a good separation point, and you should really think hard on whether there's an actual use case, particularly when you're talking about interdomain stuff that isn't even spec'd. My instinct is that is maybe not something worth putting the effort into. Thanks.
Okay. Thank you. So let's move to the next topic, Richard. So given the time limit, actually, I want to ask you, maybe you can limit your presentation to 10 minutes.
Sure, I will. So just make sure you have my latest slides, right? Qing?
Yeah, I already uploaded.
Updates. Oh, wonderful. Yeah,
Yes.
Just I made some edits. I don't want to.
Okay,
Can I start?
go ahead. Yes.
Okay. So I'll talk about auto transport. That's a charter item, and right now there's a small team of people, Roland and Danny and Chunshan. So we're working together. We're discussing about auto transport. Of course, the long-term goal is to provide some kind of one thread or effort to address the working group, the charter item, which is auto transport in new protocols. But overall, we actually take a slightly broader from the fundamental approach to design the auto transport. Of course, this is only one small team right now. Other people are giving all the feedback, but currently that's really the current result from this four-person team. Next slide, please. So the high-level goal to really address this working group charter item, we decided to actually do a slightly more systematic approach. We're not designing anything new because before we really design anything new, we decided that we should have systematic approach. Of course, long-term goal or the ultimate goal, for example, by next year is really try to push for the deployment, not really design something super fancy. So we should address real issues. Therefore, the auto transport currently we focus on lately focus on the following 4 items. Number 1 actually is to systematic analyze auto transport workload. If you want to talk about transport, you really need to understand what services and what the requirements of services we're dealing with before we talk about we design a HTTP2 or HTTP3. And then after we have the workload, and then we want to really very quickly start to really set up environment and to evaluate the performance and effectiveness of current auto transport. In particular, base protocol using HTTP 1.1, 1.x, and then also RFC 8895 and auto SSE. So therefore, then we want to really do benchmarking and understand where exactly the weak points really are. And then we also get started to talk about the design and benefits versus no benefits of integrating the new transport. For example, HTTP2 or 3 into the auto transport. So therefore, we're getting started, which we have some initial efforts, but that's actually a part of the effort as well. And then finally, of course, this one is absolutely not in the charter, but we also think it'd be quite interesting that when we are designing the new transport using HTTP2 or 3, and also take a look at the transport or generic transport of network information to application transport. So what exactly other transport are doing, so therefore make sure our design would fit into the bigger picture, or at least be comparable, and then we can use other people's design as well. So therefore, those are the four high-level goals we're working on. And now let me go to the bit details for every single one of them. So this is the first line of work which we did, and lately I think after the charter is approved. So basically what we did was we had this, of course, there's a much longer version, but here is, we don't want to make the slides to be too busy to read. Here we did a work of listing all the major auto services. For example, if you look at the left column, the uppermost column, that's a list of all the major auto services which we think we are dealing with. From beginning, of course, you provide information resource directory, and you have network map, you have a cost map, and a filter map, endpoint property service, and endpoint cost service, cost calendar, unified properties, path vector. They're ongoing. I think they are getting somehow to the endpoint, and CDI capabilities and footprint. So those are the services. The second column gives us the design. So what kind of input we do, and are they really get service or post service? And if it is get or post service based design, and what kind of input do we have, and what kind of output do we have? So what encoding it really is, and so on. So therefore, that is a second one we analyze. And then we talk about self-OB. Okay, what exactly is data structure? Because oftentimes transport depends, effectively oftentimes depends heavily on the dependency, on the structure, on the query, and so on. So therefore, we classified all these kind of different services and what kind of fundamental data structure using. For example, network map. Well, let's take a look at the cost map, the third row. It's a basic infrastructure, and it's key value store fundamental, but in an interesting way that auto was designed and based on the historical design of RC 7285. It's a 3-level of key value store, and you index from the source network map to the next to the destination, and then index into the values. And this one will be dependent on network map. So therefore, there'll be dependencies with other information model. So therefore, how to handle this. And then we analyze the scaling of the each information resources, how much data we're talking about. For example, here, let's look at the even a simple one. Let's look at the network map, for example. And we did some analysis. We said, oh, okay, the size of this one will be proportional to the number of CIDR, because that's where you group a network. And therefore, we did some initial analysis. For example, even for a very simple one, let's say, for example, you want to model the global internet, you want to really aggregate everything together. And if you don't do, for example, aggregation, and you want to transport information, then we're talking about 866. That's actually we just 870 CIDRs we're going to transport for the global BGP prefixes. So therefore, that's the size we're talking about, and about like a 900K or 800K addresses. So that'll be huge if we want to really address it in that way. Then we analyze the transport and
Richard,
what kind
you have
of.
4
Oh, 4 minutes. Yeah, actually, I don't have a lot of slides. So next one, we talk about okay, and what kind of stability expectation. Oh, can you go back?
Okay.
I'm not done with the previous slide yet, because that's important. So next one, we also start to really analyze the stability expectation of all the transport. So for which one will be stable, we anticipate. Of course, different deployment can be different. Some one can be dynamic. And we talk about if you really do, it's not stable, and what kind of incremental changes you have. For example, red column showed the potential operation we need support, because they have different implications on scheduling and also on the capability of transport, as well as on efficiency. Okay, next slide, please. Next, please. Okay, so given us analysis of all the services, which is very nice, and then this is our current plan effort before we really do the design. We want to get initial results. So therefore, Danny and I and Roland and Trinshan, we started to talk about it. So right now, our decision is we're going to, first step actually is evaluate the current transport efficiencies, and also provide initial like benchmarking, like token services or auto services. So therefore, this moment, it's very generous. Binox is fully open to use its infrastructure as an evaluation environment. We can evaluate all kinds of transport. And the Greater Bay Network, which is like a quite a large network covering Hong Kong, Shenzhen, about 13 cities, and also open to use its infrastructure to evaluate all the transport, and also as a way to model their networks, for example. Then for the very basic one, evaluate transport, we right now decided to deploy 5 benchmarking services. You can call them like some kind of like an auto transport spec. So that, for example, we filter the cost map, and endpoint unified property map, and CDN node, because there are CDN nodes inside the network, and we model them as well. And then we do flow detection direction based on the flow director, and pointing to the CDN nodes. And then we also deploy the passive vector, providing available reservoir bandwidth for all the networks. So therefore, actually, we're really trying to use them not only to transport, but also model those networks by themselves, in particular Greater Bay Network. It is a relatively large network. And then we're going to evaluate the transport. Oh, I have 2 minutes. So transport 1 is 1.x, of course, keep alive, and 2 and 3 initial design, and then we call it auto SSE. And then the right-hand side, the last column is collecting metrics. For example, what kind of metric we want to collect? I want to see sort of what we can compare with different transport. Next slide, please. So here is the initial design, and initial, of course, this is really benchmarking initial design. I don't want to say this is in any way or form finalized design at all. So therefore, that's the initial design about design auto transport using HTTP2, not 3, and only 2. So the left-hand side is the auto SSE, which RFC 8895, and initial current design is based on that design, but we want to move this one into the right-hand design, which is auto, right now we call auto H2 and HTTP2. So therefore, basically moving a lot of control channels and so on into the HTTP2 design. Next slide, please. So here is a list of requirements, and so basically, we want to use the same, all the resources possible using this design, and you can do the addition or deletion, and you can signal the start or stop, essentially like what auto SSE can provide already. And of course, very important part, actually challenging part is R4, how to do incremental updates. And then we also talk about is, yes, if we're doing HTTP as the transport, we want to make sure we follow all the semantics and so on. Next slide, please. So here, the main design issue is that, okay, I'm running on, I only have 18 seconds left, would be how do we really encode incremental updates? And because really one very nice design about SSE from all the features and so on is we allow you to send all real information, and you can do JSON patch, you can do JSON merge patch. It's very flexible, but how do we really encode it using HTTP2? Next slide, please. Oh, so that's the initial design. So therefore, here is a list of initial design, and initial design 1 is incremental update stream is equal to single HTTP stream. So therefore, we do essentially now we have a content indication layer to encode what kind of content type it really uses. And so therefore, one way is to use exactly auto SSE. So therefore, we use them as possible, or we can design a very simple content layer. The second one, of course, I think that's really one suggested in RFC 8895 section 3.3 is for every single update, we open a new HTTP2 stream, and which one will be good and so on. But the major problem here is we might be violating the push promise. But overall, I think that's problem HTTP2, meaning they are really not designed for push notification or increment updates. They're mostly essential like prefetch, designed for web page prefetching. Of course, we can talk about option of HTTP2 extension. Next slide, please. Yeah, so this one basically says that's also the space we're serving in. We take a look at that. Actually, Auto is one of the efforts in IETF to send network information application, and also IETF has effort of RPC 3168 to send ECN. There's also effort, for example, from 3GPP, and we want to make sure our design will be compatible or as much matching as possible. But that's of course the side work. We're mostly focusing on the early part. I think that's all, and then I'm willing to take questions as much as I can.
Okay, thanks, Richard. So Martin.
Sure.
Thanks. Yeah, I read the draft. I was a little confused on where you were going with it, and which maybe is appropriate for an initial shot. So thanks for that. I do. Well, it's fine to, like, as an introductions, talk about multi-streaming ahead of line blocking and stuff. Like, I mean, we don't need to write a specification for just taking existing like 7285 requests and responses and putting them on multi-streaming. That should not be a focus of the spec. I think we need to look at things where you'd actually modify the mechanisms. And you alluded to that with like the push versus SSE. And by the way, as a comment, like H3 is push 2, so that should be. You don't need to treat H3 as a separate thing. The only mechanism I could think of that isn't there is priorities. I don't know if you would want to leverage priorities, but
we do. For example, they have dependencies, and we won't even use all the dependencies. For example, when you do the resource allocation, exclusive new stream, and so on. So therefore, we do want, because the like cost map and network they do depend on. So the allocation you want to give resources, that dependencies you want send updates to network map before the cost map. Otherwise, it's just increasing the buffer.
Yeah, I mean, it sounds like you're going the right direction. I just want to steer you away from writing a lot of text about, just taking 7285 request response and putting it on H2, because that should be seamless. And just focusing on really what the new APIs are that H2 and H3 give you, because that's what needs to be spec'd out. Thanks.
Sure, definitely. Great, thank you.
Okay, thanks, Richard. So let's move to the next topic. Yeah. I think it is Gaokai. We talk about G2. So Gaokai, do you want to share slides?
Yep.
Or you want to
maybe you can share a slide. I'll just say next.
Okay.
So does everyone see the slide now? Okay, I just see the slide. So hello everyone, it's me again. So today I'm going to give some update on our integration with G2 system, and I think as they have some like IP issues, so probably we more focus on what kind of services can be provided with it with this system instead of how they are being realized inside their framework. So today, basically, I'm be talking about the bottleneck service with Auto. And so next slide, please. And in this talk, basically, we cover like 4 aspects. So first, we give some basic concept of the bottleneck service, and we give some use cases of how this information can be used by applications to better orchestrate the traffic. And then we give some basic information about the G2 optimization framework, and then we give some immature designs, or basically some advances that we want to make to integrate this bottleneck service with Auto. So next slide, please. So here we basically give an overview of what the bottleneck information as a service. Basically, we try to argue that the bottleneck information can be provided as an Auto service. I think here are some a few points. First is many networks use dynamic resource allocation to improve network utility. For example, in many networks, we basically use TCP as a congestion control to allocate like bandwidth resources. And the TCP congestion control is actually can be modeled as one of the optimization problems that dynamically allocate resources based on like different attributes. And also we now many like cloud platforms or orchestration systems, they basically manage the resources of these infrastructures using dynamic resource allocation. For example, in Google's WAN optimizer EWE system, they actually use some form of maximum fairness to allocate the resources between different flow groups. And the bottleneck information is actually important for applications to predict network performance and also get guidance for the traffic optimization process in such networks. Basically, we will list some examples, including throughput prediction and also optimization for time-bounded flows by rate limiting the application's own flows. And also, G2 papers also talk about like use cases such as network planning, but we do as we want to we want to find that the common services provided by bottleneck service and the auto service. So we will be mostly focusing on the first two use cases. And I think the last is bottleneck service can be important motivating use case of auto. We already had the Geo system. They already get a lot of some initial researches and also software development, and even with some simulations on network simulators. And I think they are actually moving towards some potential deployment in networks for supercomputing or software-defined WAN optimization. And I think so this service can be valuable for future deployment. So next slide, please. And here actually are some definitions for the bottlenecks. So the first is basically the dynamic bandwidth allocation is usually based on some optimization problems. For example, for maximum fairness, we can the system is trying to maximize the minimal flow allocation for the traffic in their network. And in the general sense, we also have many, for example, TCP congestion control. They actually allocate resources based on some unconstrained network utility maximization problem. And for these problems, we can basically have some formal definitions of the bottlenecks. And if we describe them in English, they basically, it can be implicated as if we increase the capacity of the links, then the rate of the flows can be increased as well. So basically, that's an informal definition of the bottlenecks. So next slide, please. And here we actually have an example of what bottleneck links looks like. Assume in this network we have like two links, L1 and L2, and we have three flows, F1, F2, and F3. And if the network is allocating resources based on maximum fairness, then we can actually using the definition that we just introduced, we can see that the bottleneck of F1 is actually L2, and the bottleneck for F2 is L1, and bottleneck for F3 is L2. So next slide, please. And with the analysis we just made, and we can actually draw a graph of the bottlenecks between the links and the flows. And for the network we just described, its bottleneck structure looks like something in this page, and we can see that the directions of the, for example, we can see that if an edge is pointing from a link to a flow, basically it describes that this link is the bottleneck link of the flow. And if a flow is pointing to a link, basically means the link is not a bottleneck of the flow, but the rate of the flow would have an impact on the link's fair share of the other flows. And with this structure, it enables quantitative analysis of bottleneck links or flows over other flows. So next slide, please. For example, if you want to answer the question of what happens if the capacity of L1 is increased by a small amount of traffic like delta. And next slide, please. So we can propagate this change along this bottleneck structure, and we can see that, okay, if we increase the capacity of L1, then the rate of F2 can be also increased. And next slide, please. And another type of question is, what if we increase the, what if we decrease the rate of, for example, F3 by delta? And first, with the bottleneck structure we just described, if we decrease the rate of F3, the bottleneck structure actually changes to the structure in this page. And next slide, please. And again, we can analyze how this rate change can be propagated along this bottleneck structure, and then we can analyze how other flows might be impacted by this change we just made. So next slide, please. And with this bottleneck structure, we actually can analyze. So the first use case that we can provide is provide a throughput prediction service. And in this service, basically the application can specify a set of flows, and then the server would be able to answer what is the predicted throughput for this set of flows in the network. So next slide, please. And basically here is a concrete example of the throughput prediction service. So assume we have 3 background flows, F1, F2, and F3, and a client wants to query the rate for F4 before even establishing the connection. So the server will be able to, the server needs to monitor the background flows, and then, so next slide. And the network, the auto server basically can add the new flows to the network and then analyze its bottleneck structure. And with this bottleneck structure, it will be able to predict that the rate of F4 is actually 0.67, actually like 2/3, for example, megabit per second. So then it will be able to answer the this throughput prediction service. So next slide, please. And another use case is, for example, in the G2 paper, they actually describe the case where you want to speed up a certain flow, but you can only rate limit some flows with lower priority. And then to enter this, to be able to solve this kind of problem, it can also use the bottleneck service. So next slide, please. And for example, assume that the application wants to optimize the rate of F5 to be 0.8, and it can only rate limit flows F2, F3, and F4. And then it can, for example, query the auto server and get the response as the next page. And for this query, it actually, if we look at the flow gradient bottleneck structure, then we can see that with this bottleneck structure, we can actually derive how different flows would impact the rate of the target flow. And basically, we list the values on the top, and from this page, we can actually see if we rate limit the rate of F2, it actually does not help us to increase the rate of F5. So in this page, with this information, the application can choose to rate limit F3 and F4. So next slide, please. And again, when we try to rate limit F3 and F4, then the bottleneck structure would actually change. And with this in this new bottleneck structure, we can actually get a quantitative analysis. For example, the old rate is 0.5, and we want to increase the rate to 0.8, and then we can actually calculate the delta using the information, and then we get the delta should be 0.3. So we can, so next slide, please. Yep. So So basically, we just give these two examples to demonstrate how we can use the bottleneck service to solve like flow scheduling problems in the application. And here is an introduction for the G2 work. Basically, G2 is an optimization framework that based on this quantitative theory of bottleneck structure. It develops some efficient algorithms to compute the bottleneck structure that we introduced, and also it gives some examples of how you can conduct application layer optimizations for their own flows with in networks with maximum fairness. And I think the G work is getting a lot of attention in both academia and in industry, and they are actually they have some ongoing deployment efforts in both like supercomputing networks and also with data center networks. So next slide, please. And here is some examples of the evaluation results that they get from their studies. So it has shown some potential in predicting throughput for TCP traffic, and also demonstrate many use cases such as optimal rate path, network planning, and the TE for time-bounded traffic that we just described. That these types of use cases can be effectively solved using the bottleneck structure. So next slide, please. And in the next few slides, we just give some initial idea of how this service can be provided both with auto as the southbound and also with the northbound. And basically in this slide, we focus more on the providing the bottleneck service as an auto, basically using auto as a northbound. So next slide, please. And we summarize the requirement that we just get from the use cases. For throughput prediction, we need to specify like flows and their status, and we also need to get the throughput prediction results for these flows. And for the second use case, we not only need to get the flows, specify the flows and get throughput prediction, we also need to specify like some customized linear constraints about the flows, and also we might need information about the bottleneck structure, including link gradient and flow gradient values. So next slide, please. And actually, the bottleneck service can be provided for some specific use cases, even with the current auto based protocols and extensions. For example, if the auto server is providing the throughput prediction for site level flows, for example, the flows are between different networks, for example, between different data centers, and there are resources allocated by using some kind of maximum fairness. Then if we model each data center as a PID, and this information can already, so this type of information can be provided using some existing auto extension. For example, here we need to specify whether the flows are established or are unestablished or already established, and then we can use the cost metrics from the performance metric extension, such as throughput, as a cost metric, and then in the response we can actually return basically the throughput for the predicted throughput for each flow. And next slide, please.
Can you wrap up?
Sure. I think we only have like a few pages. And also we can also specify the throughput prediction for like TCP level flows. So next slide. Yeah, actually, and also we to support the use case for time-bounded data transfers, we also have some initial design. So next slide, please. For example, in this, we actually use the multi-cost extension to specify to get multiple information about the bottleneck service. For example, we need the throughput and also the flow gradient information, and then the response will contain both the throughput and also the flow gradient, and the flow gradient information can be used by the application to decide which flow to be rate limited. So next slide, please. And the application can add the rate limit as flow basically constraints to the flows, and then the auto server can predict the new throughput based on the constraints. And basically in this example, the application can get the expected flow rate for its own target flows. So in 2 iterations. So next slide, please. Yep. So here is a summary of this talk. So our first argument is that the bottleneck service can be useful in many networks, and solid work has been established by G2 for maximum fairness and is moving towards like real deployment. So and we also believe that bottleneck service can potentially be integrated as part of the auto framework. And basically, we are interested in if the working group is basically how we can proceed with this work. Is there any interest from the working group to standardize this type of service? Yep, that's all. Thanks, Chin.
Okay, thanks, Kai. So Richard, I think we don't have time. Can we move to the next presentation?
Okay. Yeah, I mean, just like one very quick. So basically, the G2 team presented to the auto team and meetings, and they have tremendous interest. I think this actually can be a very good use case for auto deployment. We can focus initially not really extending auto, just use existing auto for deployment. But later, of course, there's some like a fully user feature. We might need like to do a little bit like a simple addition. For example, inside the current filter, we add like flow level filter, which is very simple, essential like a MIME type.
Yeah. Okay. Thank you, Richard. So thanks, Kai. And then move to the next, Danny. Do you want to share slide by yourself? Or?
No, could you share the slide, please?
Okay.
Yesterday, I sent.
Yeah, I get
another version. Yeah, new version, right? Slides are coming, I think.
Yeah.
Okay.
You're up.
Okay. Yeah. Okay.
Go ahead.
Thank you. Okay, this is Daniel from Venox, and today, I would like to present a couple of slides with information about the implementation and deployment experiences with Flow Director. And next, please.
Oh, sorry.
Oh, no problem. Next. Yeah, let's start with Flow Director. So in few words, basically Flow Director collects data from the internal state of the ISPs. Basically, it builds an inventory from the front warden and control plane. Secondly, Flow Director, computes the bits mapping and compiles that into an accessible database. And finally, communicates this information to the hyperjams. Just to quickly introduce this term is, hyperjams for us, at least, there are multiple definitions, are large networks that provide services mostly to the end users. They are globally distributed and generating, a large amount of data, for example, like my Facebook, Netflix, and so far and so on. And basically, Flow Director communicates the network information to the hyperjams that want to collaborate using different protocols, including the Alto protocol. Next slide, please. Just a couple of words of the history on this. It took more or less 10 years in research. Oh, the next.
You want to move to page 4?
I can move, or no? Yeah, you are
page
in
3.
Four should be.
Next slide.
Yeah. Basically, like I say, this took more or less 10 years in research and about 7 years for the company to get the point where Flow Director is now. Between the first evaluation and the actually going live is more or less 7 years. And Flow Directory, was also built horizontally scalable, and all the components are adhering to the RFCs. And currently, basically, we run a fairly large environment with over 1 gigabit per second of net flow data, and we hold about 600 BGP sessions, more or less. Okay, next slide, please. regarding the architecture, basically we have three main components. It's outbound components that are basically for data collection and aggregation. The core engine, which does all the model building and calculation. And we have the northbound component, which does all the communication of the path ranker to the hyperjunks or CDNs. We have, Alto or others like a northbound interface like CSV or out of bands BGP interfaces. Okay, next slide, please. So now let's go into the operational experience to talk a little bit about this. Okay, next slide, please. First of all, we have a collaboration with one hyperjunk. This hyperjunk had more than the 10% of the total traffic inside the ISP's network. Basically, there were two KPIs to consider. For the ISPs, we wanted to reduce the long-haul traffic, and for the hyperjunk, we wanted to reduce the latency. This is basically bring the server closer to the user. Flow Director basically uses a mapping function that is a combination of the path length and the distance. And just to say that Flow Director basically, when it gives a path ranking, this path ranking basically is a suggestion that it can be ignored by the hyperjunk. Okay, next slide, please. So now to talk about the benefits for the ISPs, for example, what you can see here is basically the traffic of the hyperjunk of the backbone and long haul links. And you can see here the traffic on the long haul links are, in constant decrease. Basically, we deployed Flow Director into 5 phases. And one of the interesting things is in the whole phase in the middle. You can see in this point, the traffic, especially in the long haul traffic goes up. This is basically because there was a sort of misconfiguration and the mapping was reset to random. But when the system were enabling, the traffic went down. And at the end, we have a significant reduction, especially in the long haul traffic, which is the most expensive for the ISPs. Okay, this is basically one of the benefits for the ISP. Next slide, please. And in terms of the benefits for the hyperjunks, like I said before, we use the distance as a proxy for latency. So in terms of the distance, we reduce the gap, that is the distance between the server and the clients, are reducing by about 40%, which means that Flow Director localized the traffic. And again, you can see here in the whole phase, this goes up really high, because the mapping got broken. But at the end, when it was restarted, the traffic went down again. Okay, next slide, please. Now, just to give a little bit more information about, or in terms of the alt implementation and deployment experiences. Okay, next slide, please. Just to give an overview about what was implemented or deployed. Currently implemented is the base Alto protocol with all the provided features, information resource directory, network map, filtered network map, cost map, EPCON services, etc. Here one point is that we differ from the RFC in at least one point, that is our endpoints are not the IP addresses, they are the IP subnets. Therefore, we don't identify just one host. Okay, and in case of the incremental updates, this was partially implemented because two reasons. It was still a draft when we started the implementation, and also it requires some structural changes because it's a little bit quirky. And in terms of deploy it in production, we basically have the network map and cost map features. Okay, next slide, please. And the scenario where we were currently operated, or it's a CDN that wants to deliver content to the ISP's customers. Basically, we're considering only paths from the CDN caches towards the customer. This is because, the main traffic simply flow from the CDNs to the end users. And, the CDN caches are not only embedded into the AES of the CDN itself, but can also be embedded in the foreign AES. And one interesting question here is how to group the prefixes for the PIDs, and at the end create the alto resources. Next slide, please. Okay, just to quickly provide info about how to the data is accumulated with routing protocol. We collect information about the links, router, networks with flow information. Obtain for example, from NetFlow, we can collect ingress or egress points, and we can get information from the network monitoring to try to collect information about the utilization, bandwidth, latency, etc. Okay, next slide, please. Okay, just for the alto max calculation, we are attached to a large European IXPs. You can see here there are a lot of routers and IP prefixes. So yes, I see you can see all the details. I don't need to repeat all the information. Next slide, please. Okay, for the network map, we basically defined 3 different PIDs: internal, external, and OGNET. OGNET basically for prefixes from directly peered ASs. This means not third-party traffic on peering links. Yeah, see, next slide, please. I think the time is going to. Okay, for cost map, basically we provide 3 different cost maps. The hop distance, that is the cost in terms of number of AES internal hops. Path weights, that is basically the cost according to the routing protocol. A custom cost, that is divided from the delay or peering link utilization. Okay, now I think next slide, please. Okay, some statistics from our Alto running server. So all the network maps, cost map are updated every 5 minutes. We have more or less, 250,000 prefixes across 1,700 PIDs. And the average map size is about 6 megabytes. And in case of the custom cost map matrix, we have more than 1.3 million of PID pairs. And with the average size of the cost map is more or less 47 megabytes. Okay, we can go next. Okay, yeah, obviously we experimented some problem because we are working over a large network. So we have, for example, a long running for the maps calculation process. In this case, a new network map is always available first than the current available cost map. And on the other hand, there is a limitation to the IP addresses in the endpoint conf services. The RFC states that the source and destination must be an IP addresses. However, we want to get the cost for certain region. We are connected to request prefixes for clients of NEPs. Next, please. We consider a set of modifications to deal with the previous problem. For example, mechanisms to publish all maps together when the last one is ready. On the other hand, our Alto server support prefixes in the endpoint comp services, and we also adding metadata fields like TTL timestamps in the Alto server response. Okay, next slide, please. Just to quickly summarize, for us, we consider that there is an opportunity to operate networks more efficiently through network and application integration. Today, I wanted to briefly show how this collaboration works in a system that is currently deployed, and it works for both ISPs and hyperjunks. In terms of next steps, the idea is, is to contribute with data through implementation and deployment experiences documentation. And while, Alto is not a highest priority activity in terms of implementation for us, we are like Richard said, we are fully open to use our infrastructure as an evaluation or testing environment. So I think that's all.
Okay.
Thank you so much.
Okay. Thanks, Danny. And I think glad to see Flow Director has already been moved to production stage. So thank you for sharing your problem and limitation you found in the auto implementation. I actually suggest you can take to the list to have some discussion. It will be good input to the auto deployment experience update. Yeah.
Sure. Thanks.
Okay, Rachel, we don't have time for comments. Maybe we can discuss on the chat room. And for remaining topic, actually, we have 3 topics. I suggest we actually condense each topic to 7 minutes. So the first is Luis. Luis,
Yes.
do you want to share slides by yourself or you want me to share?
I prefer you share. Thank you.
Okay.
And yes, I will try to be brief. And
Okay, great.
so, okay, I can see now the slides. Thank you, Chin. So the idea here is to present this work, which is considering Alto as IETF network exposure function. And I count with contributions also from Shun-san and Xiong. So, yeah, next, please. Yeah, the motivation of this work essentially is to understand that networks are becoming consumable more and more by application and services. We are observing this trend, and where there are discussions in other working groups as well in IETF about this idea of application network integration or network application integration. So different ways of interchanging and exposing information and capabilities in one direction or the other. So this is also a trend that is being observed in other initiatives outside IETF. So these new forms of exposing capabilities. And yeah, the final idea at the end is to inform or to allow applications to get informed about the situations of the network, and in such a way that these applications can take better and optimal decisions. So it's been, I mean, moving from the decoupled way in which today applications and services are running to something much more, informed based. So trying to avoid that inferring or guessing of about network capabilities and status, and basically collect information that could be useful for the application and services to have better optimal criteria for the delivery. There are a number of examples in other, let's say, solutions on other networks. For instance, the 3GPP network exposure function that somehow is an inspiration for this work, where network functions can be informed, application functions, sorry, can be informed about capabilities of the 3GPP overlay network. Also, we have other initiatives like the ETSI multi-access edge computing APIs, where these APIs can provide information about the capabilities of the access network, or even radio information, and so on and so forth. Same story, same idea for the ORAN RAN intelligent controller, and so on and so forth. Next, please. So Chin, okay, thank you. So Alto in fact was conceived from its inception as a mechanism for providing information to support optimization decisions on applications. So in this sense, Alto seems to be very well positioned to take this role of network exposure function for IETF capabilities. Initially, the possibilities of the information that can be exposed by Alto are the topology information that is now being expanded to a number of other capabilities, as performance or segmenting view according to the path vector, etc., etc. We saw at the beginning some of these possibilities. So taking into account these capabilities, somehow we structure in the draft different possibilities of information exposure. So somehow we are collecting a kind of catalog based on existing and foreseen work. Regarding existing work, and assuming what is documented in RFCs or documents that will become RFC soon, we could count on a network topology, associated cost metrics, performance metrics, this segmented view leveraging on the path vector solution. And also we could even try to cover some other cases that are not actually documented at all, but can be straightforward, like the dynamic IP addressing that could come, for instance, for the control and user plane separation trend both in fixed and mobile networks. So dynamic UPF instantiation or dynamic BNG user plane instantiation, for instance, where you will have a dynamic allocation of IP addresses to those instances. Also, we can account on information that is exposed by proposed augmentations. And here, maybe we can talk about the optimal service edge. Also, the underlay view for overlays, these overlays, the cellular network or the CDN, and so there are also some individual drafts now in the group. Analyzing those situations, and also just to comment other information, other potential information that could be exposed has been also discussed in the weekly ALTO meetings. This is not yet documented, but the idea, according with the progress of the discussions, would be to document them and to be included in the draft. And here we could mention, for instance, multipath approach, multipath support could be something that could be also part of these exposure capabilities. So next slide, please. Thank you. So here just a view of what could be graphically or for illustration purposes, what could be the interaction between ALTO as a network exposure function and potential clients of these capabilities. We could have external applications. Here we can account on external CDN logic. So we could consider external CDNs like the case that Danny presented before, or internal CDNs that, for instance, is the proof of concept that Telefonica is integrating with the internal CDN. But also we could consider cloud application orchestration or 3GPP network exposure function or whatever other customer or external overlay network that could leverage on IETF capability, IETF network capabilities. And also we could have a number of internal customers like SDN controller, the CDN logic that also has been mentioned, and so on so far. Maybe some other sources of some other applications, sorry. The idea would be to collect this information from the IETF network to feed the ALTO network. Here we added BGP, BGPLS, but there could be other sources also, as described before by Danny, maybe as an MP, or maybe directly collecting information from the nodes through NetConjunct models. Next slide, please, Chin. Also, a potential way, an alternative way of collecting and providing information would be to position these applications that are internal to the network. Here we put the 3GPP NEF as internal to the network in case that this 3GPP network is also handled by the same administrative domain. At the end, essentially the message here is to integrate, to collect the information from ALTO and to expose this information to external or internal customers through the ALTO protocol with or without the stations, depending on the kind of information. So next slide, next and final slide, please. So the idea would be to collect feedback from the working group, and for sure we are working on preparing our next version with more detail on the usage of ALTO as IETF network exposure function, with the final purpose of positioning ALTO as this IETF NEF for feeding applications and services. Thank you.
Richard.
Yeah, I just want to give one very quick comment. I think this is super, super cool. And I really wish or hope that there's some way we can push this one forward. Either, we support NEF, for instance, GPP or the other way around. But overall, I think this should be very interesting work. I strongly support and very interested.
Okay, let's move to the next topic. Leopold, do you want to share or?
I can share by myself since the time is not so enough and some slides need to be quickly go through. So my screen available?
Yes, go ahead.
Okay. Hello everyone. This is Pony from China Mobile, and it's computing aware networking use case of Auto. First is the background. It's about the ICT infrastructure definition. So the service providers offering the integrated computing and networking infrastructure to provide the best use case user experience, such as low latency and high reliability, and optimize utilization of network and the computing resource. But there are also some challenges of edge computing, such as geographically scattered large number of edge sites, resource limitation, and hedge nearest hardware, dynamic load, and others. So the problem is that um, all of the challenges are not solvable solely in computing domain, nor the network domain. So we need to find a collaborative approach. It's a use case that we want to see is that both of the network and computing factors in the same level to influence the user experience. So it's better to have the scheduled among the different edge sites to find the suitable one to offer the service. Yeah. Due to the challenges and the use case, we put up the computing-aware networking. Here is the definition of it. Computing-aware networking is proposed based on the ubiquitous network connection and highly distributed computing resource. It proposes new mechanisms to be aware of the distribution and status of computing resource in network and combine service framework optimal routing and load balance to schedule the computing and network resource based on the awareness of service request. So to improve the efficiency of the computing and network resource. And something need to be clarified is that the relationship between C and the diecast, since I has joined the meeting as previous IETF meetings. So diecast is a key function of computing-aware routing layer, which has a potential opportunity to do something at IETF. Besides this, the CM framework also has the network resource layer, computing resource layer, computing service layer, and the management layer. And here's the potential relationship of computing-aware networking and auto. For the framework, the computing-aware networking can realize awareness, control, and scheduling of computing and network resource, and perform dynamic and on-demand service scheduling. The function of computing and network management layer may be realized by auto or by opening some interface with auto server, which include two aspects. So one is deployment of CN with auto. Most stable static information should be considered in service deployment, such as network topology, computing topology, and so on. Unlike the request scheduling, service deployment should still follow the principle of proximity. If the results are insufficient, the operator can be informed to increase the hardware resource. So the auto can be used to transmit information. It has a similar idea with draft auto service edge. And another aspect is scheduling of seeing with auto. Scheduling needs to consider more dynamic information such as mobility, status of network, and computing, and service requirements. And also, auto also can help collect real-time network service node information, providing the best service of network and service nodes based on the collect information and the service requirement, or providing data analysis and policy distribution. Real-time node selection still depends on distributed routing, such as diecast. And we exactly know that satisfy the same framework or any components of it might not be the substantial work of auto now, but the trend of infrastructure definition may bring the new opportunity of it, since it can help to give the suggestion to deploy the service node and collect some useful information. If the network can get the computing information, it can also send to the auto server. So here are some questions received from mailing list. Question one is multi-protocol or one protocol to use to collect the information. We think multi-protocol will bring the issue of synchronization, which is not easy and cause some additional expense. If the network is deterministic network, may can support synchronization. So one protocol may be a right way. Maybe extending BGP can be an option, but the frequency is a problem. And another question is that to decouple auto from the specific CN architecture, it's a good way to really to combine them and to also find some way to solve the problems now. Yeah. And the last question is that requirements of real-time information, how to shorten the period of information refreshment. So real-time is good, is an important factor in the CN framework, and we can find some information in the existing RFC. The auto service may not have the real-time information for the network or the routing. So it's a potential challenge or problems to realize these functions. So
you need to wrap up.
Okay, yeah. So it's the last one. Okay, that's all. Thank you.
Okay, thanks, Liu Peng. So thank you for your input to auto worker. I think you raised a lot of good questions. Suggest you take it to the list, have some discussion. Thank you.
Okay.
Let's move to the next topic. Liu Zixuan.
Hi, I'm going to share my screen.
Okay, great. Can you send a request? Okay.
I think I have sent it.
Okay.
Yeah, can you see my screen?
Yes, go ahead.
Okay, let's get started. Hi, I'm Zhixiong from Microsoft Research Asia. I'm going to give a talk on bandwidth estimation on OpenNetLab on behalf of OpenNetLab community. This talk is mainly focused on to introduce the bandwidth estimation and discuss the possibility to make it as a part of auto. As we know, RTC is going very fast recently. Compared to January 2020, the active user increased by 3 times, and the number of calls and the meeting increased by 7 to 17.4 times in April. I think the most important indicator reflecting the user experience is PCR, pull call rate. In the figure, we can know that the number of pull calls and the pull call rate are increasing dramatically when the COVID-19 outbreaks in US on March. So it's a very urgent for RTC to continue improving our call quality to attract more users. Bandwidth estimation actually is one of the key reasons of the pull call rate. In the table, we list the top 10 reasons for pull 11 calls. You can know that 28.9% of pull 11 call is highly related to bandwidth estimation, and 40.9% is related to bandwidth estimation. The problem includes the no sound, distort with audio, background noise, audio delay, call dropped, video low quality, and the video freezing. So there's a question come to us. Can bandwidth estimation can be a service to make everyone can contribute to it? Let's see the traditional bandwidth estimation. You can see it has many interfaces with different modules. And also for big company, the bandwidth estimation are proprietary. That means every company has its own design and implementation. It's kind of closed. So it's usually use single model for all users, and it's hard to innovate in this area. So I think we can use the concept of auto to make bandwidth estimation as a standard service. It can make the architecture simpler and make the service open. It can enable more customization, and everyone can contribute to this service and share the technology of the service. To boost the innovation, actually, we have a bandwidth estimate challenge on MMCs this year. The goal of the challenge is to optimize the QoE for real-time communication. For example, the video and audio call quality. And every participant should design their bandwidth estimation model or algorithm to compute a bandwidth to estimate the current bandwidth based on the network status. We use OpenNetLab as the testbed for this challenge. In the evaluation period, actually, we use more than 40 run per schema on OpenNetLab. It includes 9 videos, 3 networks, including high, medium, and low bandwidth, and we have 5 runs per schema in a round-robin way. The final score is the average weighted sum of the video score, audio score, and the network score. Finally, the Nanjing University team is the winner, and their score is 78.33, which is better than the Google congestion control, which is 71.47. We can see the innovation is very promising in the bandwidth estimation. And we can also see bandwidth estimation can be a part of the auto. The figure 1 shows the location of the auto service and the auto clients. The server can be independent or live with the clients. The client can request the bandwidth through the interface. Actually, they can use the standard auto interface to communicate. The potential application can be RTC, such as Teams, Tencent Meeting, or also some other RTC software. The input could be packet states, and the output can be the estimate bandwidth to the sender. Of course, the input and output can be changed, adapt to the need of the application. By the way, all of our research actually are on the top of OpenNetLab. It is a kind of data-centric networking research community. The community is founded by 9 top universities across Asia, including Nanjing University, Peking University, Tsinghua University, and also Microsoft Research Asia. Professor Tian Chen is the chair of the community this year. I think due to time limitation, I think I can give a brief introduction of OpenNetLab. It provides a framework and also heterogeneous nodes to achieve the data-centric networking research. And we are building more and more nodes across Asia, and we are expanding the OpenNetLab to the worldwide to increase the coverage. Yeah, thank you.
Okay, thank you, Liu. So Ma Yunfei, so you want to make a comment?
Yes. Hello.
Go ahead.
This is Yunfei from Alibaba, and I have a question. So you just mentioned that for the pool call rate, it's 40% of the pool call rate is related to the bandwidth estimation, and I want to know how do you calculate, how do you compute this number? How is this number computed?
Actually, we just we have when you're using Teams, actually you can have some you can have a score. The user can mark it as some score, and we check the bandwidth estimation backlog, and we can compare. There are some bandwidth variations, and maybe the bandwidth is not adapted to the real bandwidth. Yeah.
Okay, Richard.
Okay. I think this is great. My question is the following. Suppose we want to integrate this one as a service using Auto. I think the API is not a major problem. We already have it. One concern is the frequency of the data. So currently in your current implementation and your BWE server, what's the frequency that, how much data and at which frequency that your BWE server is sending the information to the client?
Actually, in kind of the WebRTC or some RTC like this, we exchange the bandwidth estimation data in, I think, 200 milliseconds.
So basically, we're talking about potentially if we push auto and to send information, we're talking about several hundreds or milliseconds frequency, and that'd be good enough.
Yes. Yes.
Okay. Got it. Cool. That's very
Okay.
nice.
Okay, thank you, Liu. Thank you, Richard. So we are on time, actually. Quick wrap up, actually. Thank you for Mohammed, actually, moderate from behind, remind the time limit. Thank you for Daniel and the agent to take a minute, and thank all the participants. And any last words from Matt or Martin?
No, thank you, Chen.
Thank you. Okay, let's close this meeting. Yeah, thank you.